Our endpoint is a fuel briquette, which is a substitute for charcoal or firewood in third world countries. Primary ingredients are sawdust and paper, which we mix with water, and that becomes a paste material. We have a 4-piece mold set with separators, hydraulic jack that we use to compress the material. And when that material comes out of the mold set, what we have is a wet fuel briquette that looks like this. That is air dried, and then when it's finished, the fuel briquettes are burned as a substitute for charcoal or wood. The heat output on a fuel briquette for weight is actually higher than charcoal. You can get more heat out of a fuel briquette than equivalent weight charcoal. Production on the briquettes using the little press that I designed is as high as 1,000 briquettes per day per person. So extremely high production for a fairly simple manufacturing process. This is our basic wet stuff that we start with. And it's literally a matter of sawdust, paper, water to the point that you're happy that you've got a good wet mix. I'll try a little more sawdust, a little more paper. Third world countries where the briquettes are being made, the typical mixing is not a sealed container like this. It's an open tub, push back and forth. This is much cleaner. It doesn't slop quite so much stuff around. We're going to mix it by rolling it. We'll turn it in for end a couple times. And then we'll roll it just a couple more times. And our mix is ready to go into the mold set. Outside is a 4-inch diameter piece of PVC pipe. Our separators are acrylic glued together, 2 layers. And we use these because we have a laser that can cut them. These could be metal, they could be plastic, they can be any readily available material. Center drain pipe, piece of 1-inch PVC that's been cross-drilled with holes to allow the water to escape while we're compressing it. We're going to take about a cupful of material and we pour it in. I make some attempt to try and keep it equal on both sides. It helps the briquettes come out in a consistent shape. A couple cups of that. Then we're going to add a divider. And repeat the process with a couple more cups of material. And the exact amount per filling is not critical. Briquette sizes will change slightly, but the size of the briquette is not critical. Divider. And then this is our push tube or push pipe. We put it in. And then when we pump the jack, it comes down on top of the tube. We're compressing the material, forcing water out the bottom. And the jack comes down until we hit the top of the pipe. That tells us the compression is complete. You can hear water draining out the bottom. Release the jack. Lock it out of the way. Push pipe comes out. And we pull the center drain pipe first because that makes it easier to get the material out. And then to get the briquettes out, it goes on top of the ejector tube. And there are 2 completed fuel briquettes ready for drying. Briquettes go on the drying rack. then we're ready for the next cycle on the press. Temperatures like we have here, temperature and humidity in this warehouse, were probably about 3 days for drying. They dry fairly quickly. The rack is designed so that you can stack the racks up. This was a little innovation that I came up with, and nobody had ever gotten production to the point that drying fuel briquettes was a problem. So I scratched my head and said, how about a bread rack? This is how they dry bread, so we modified it. These stack up. You can pile these 6, 8, 10 high. If it rains, which is common in places like Uganda, then you cover it with a tarp, wait for the rain to stop, uncover it, and start drying.